This first section says to solve by graphing. And this is broken up to practice all of the types of methods. But remember what I told y'all today in class when we were going over the formative assessment. You can try any method you want. So you could start off with trying graphing for all of these on the entire review and see if it works. You don't have to use the method listed in the problem on the test tomorrow. Okay, but we're going to go through and practice all the methods because some people have different preferences. All right, so for graphing, okay, this is just asking us what the three types are. So I need my pen here. All right, so graph the three types of quadratic solutions. Okay, that would be two solutions, two real solutions, okay, or you could have something that looked like this. Well, actually touched. Okay, that is one real solution or one real root. Remember, solutions and roots mean the same thing. Okay, or you could have something like this, where the quadratic never crosses the x-axis, and that means there is no real zeros. Okay, again, solutions, roots, zeros, those are our vocab terms. They all mean x-intercepts. Okay, now if this is the case, if there are no real zeros, remember, they will be imaginary. All right, then on number 2, they want us to solve by graphing. Okay, so I'm going to get my Desmos, type in my equation. Remember, we just have to have it in y equals or equal to 0. This one says y equals instead of 0 equals. That's fine. We're just typing in this side of the equation. So x squared, is this typing? It is minus 2x minus 3. And I can zoom out and see here's where it crosses at -1 and at 3. My vertex is down here at 1, -4. You're not going to have a question asking you for the vertex, but for the sake of putting this on your review and graphing it, I'm going to do that. So -1 and 3, and then at 1, -4. So 1, 2, 3, 4. And -1 and 3 were my roots. So there's my graph. Okay, so my solutions were -1 and 3. All right, this one says solve by factoring for 3 and 4. For the sake of practicing entering things in the calculator, I'm still going to have you do that as we go through the review, or I'm going to do it. So this one is 2x squared minus 5x. Now notice in the equation on your paper, it's set equal to 3, not 0. So to get this equal to 0, we'd have to move the 3 to the left side by subtracting. So it becomes -3 on this side. And so we can see our solutions at -1/2 and 3. So I could technically stop. I have my answers, but I'm going to show you factoring for those who still need a little bit of practice factoring. Okay, I do need to get everything to one side. So I move that 3 over and have it set equal to 0. You can do guess and check factoring. Since both your A and C are prime, guess and check won't be too hard. The only factors of 2 are 2 and 1. So this has to be 2x and 1x. And the only factors of -3 will either be -3 and 1 or +3 and -1. That's where the guess and check comes into play. I have to guess which one, the 1 and the 3, where they go, and which one is which sign. So I'm just going to guess for now, -1 and 3. Now to check, remember the outer get multiplied and the inner get multiplied and then added together to give us our middle term. So 2 and -1 would be -2. And then 3, -2 and 3 would not give us -5. So that did not check out. So what if I switched those? What if I said -3 and +1 here? So then when I check, 2 and -3 would be -6, and that would be +1. -6 and +1 does give me -5. So I've factored correctly using my guess and check method. If you used a different factoring method, that's fine. You should have gotten the same factors. Once you have it factored, you split and solve. You set each factor individually equal to 0. This one I just need to add the 3 over, so I get 3. And over here I would have to subtract the 1 and then divide out the 2. So I get -1/2. Same thing I got over here on the graph, -1/2 and +3. All right, this one is in factored form already, so it's ready to just split and solve. So I set each factor individually equal to 0. Would add the over here, add 3, then divide by 2. So you get 3/2. Over here, I would subtract 12. Then divide by 4 to get -3. So I can see if factoring will work, graphing will work. Because if you're factoring and solving, you're getting rational solutions. So they would show up on the graph. So if I had typed this in as 4x plus 12, ooh. Plus 3. I can see my parabola here, and I can see 1.5, that's 3/2, and -3. As a reminder, I know I showed you this in class today, but if you have a decimal and you're like, oh, I don't know what that is as a fraction, type it in over here and click right here, and it will tell you what it is as a fraction, as long as it's a rational number. That will work. Okay, if it's an irrational decimal, like some long and they've just rounded it, that's not going to work for you. And if that's the case, factoring wouldn't have worked either. You would have to go use completing the square or quadratic formula. All right. Speaking of quadratic formula, the formula will be given to you on the test. You don't have to have it memorized. Okay, you do have to have it set equal to 0. It's got to be in standard form. So don't go over here and tell me, oh, A's 1, B's 3, C's 8, because this is not set equal to 0 yet. So I need to move that 5 over by subtracting first. So this is x squared plus 3x plus 3. So actually, my C is 3. So I've got A is the understood 1, B is this 3, and C is the constant, which is 3. So now I'm ready to plug those in to the formula. -b plus or minus the square root b squared minus 4ac all over 2a. So simplifying, that is -3 plus or minus the square root, and the bottom is 2. So we just need to figure out what the discriminant is. Remember, you can use the calculator for that. I know when I'm doing work with y'all, I do that in my head a lot. You don't have to. You can type in 3 squared minus 4, and then your A and your C. So my discriminant is -3. That negative under the radical right away tells me this is imaginary, okay? And if I wanted to check that, if I had decided to try this by graphing first, x squared plus 3x plus 3, I can see this never crosses the x-axis. So I know based on the graph that it should be imaginary. And that's just been confirmed because my discriminant is negative. Okay, so what I'm going to do here now then is take that negative out, it becomes I. If you can reduce or simplify the rest of your discriminant, the radical here, you would do that. I can't simplify square root of 3 though. 3 is prime. So this is going to stay as negative 3 plus or minus, and then that negative is going to come out as I, and the 3 has to stay under all over 2. And remember, you look at the numbers here to see if they both will reduce with the denominator. You can reduce. In this case, I can't. 3 doesn't reduce with 2, neither does 1. So that's as far as I can take it. Those are my imaginary solutions. All right, now 6, 7, 8 are having us practice, and 9 are having us practice by taking the square roots. Remember, you can only take the square root, use the square root method, when your function doesn't have more than one x term. So like here, there's only x squared. There's ax squared and there's the c, there's no bx. And these that are set up like completing the square has already been done, or they're almost in vertex form, you can do square root method because there's only x only shows up in one spot. Okay, so if there's only one x, then you can do the square root method. To do the square root method, you first have to isolate what is being squared. So here, that's the x plus 2 squared. Here it's x minus 3 squared, x plus 7 squared, and in number 9, it was just x squared. The 8's not part of what's being squared. So in number 6, it's already isolated. There's nothing being multiplied in front of those parentheses, nothing added or subtracted after. So it's already isolated. So we're ready to take the square root of both sides. And don't forget the plus or minus. So you end up with x plus 2 equals positive or negative. And square root of 64 is 8. So then you're ready to isolate x. So I have to subtract 2 from both sides. Remember, don't forget the plus or minus because you have positive 8 minus 2, which is 6, and you have negative 8 minus 2, which is negative 10. So those are your two solutions. You could also have solved this one by graphing. If I had typed this in, x plus 2 squared. Oh, why is everything else still there? 2 squared. And then I would have had to move the 64 over. It would have become minus 64. I can zoom out and I can see negative 10 and 6. Those are the same solutions I got doing square root method. Now again, notice how I had to move the 64 over from the right side of the equation so that it was set equal to 0 before I can type it in the calculator. Okay, so same thing on 7. If I were to type this one in, I would have 5 x minus 3 squared, and then that minus 45 would have to come over here. It would become plus 45. Okay, zoom out. Ooh, that one's imaginary, so I can't actually solve this one graphing. So let's go back to the board over here and try solving by hand. So what is being squared is not isolated yet, so I'm going to get rid of that times 5 by dividing by 5. So I have x minus 3 squared, and then that is going to be negative 9. And now I'm ready to take the square root of both sides. And don't forget the plus or minus. So I get x minus 3 equals positive or negative. Now, first of all, the negative under the radical, that's where the imaginary comes from. So that's going to be an I. And 9 is a perfect square. So square root of 9 is 3. So this is 3i. I still have to move this constant over. Now when I do that, I do not combine this imaginary part and this real part I'm recording. So I leave them separate. And remember, when I have a complex number like this, I put the real part first and then the imaginary part. So that's how that should be written for 7. Okay, we could test 8 in the calculator and see if we're going to have real solutions. 7, and then moving that 30 over, it would become minus 30. So this does have real solutions, but looking at those decimals, they're irrational. Okay, so I don't know what those would be as an exact values. These are rounded decimals. Okay, so I'm going to have to come back over here and actually solve it by hand to get those as exact values. So I'm going to do the same thing I did on 7 and move that coefficient out front first. So I'm going to divide 3 out. Get 10. And then I'm ready to take the square root of both sides. Don't forget your plus or minus. So I've got x plus 7 equals the positive or negative square root of 10. Now, if you have a radical that's not a perfect root, see here, 9 was a perfect square. Where's another one? Oh, here, 3 wasn't a perfect square, but it doesn't reduce. So we haven't had to do anything with our square roots until now, because square root of 10 should reduce. Remember, you can do your factor tree if that helps you. So factors of 10 would be 5 and 2. Ooh, what's going on with this stylus? 5 and 2. Those are both prime. I can't go any further, and neither one has a pair. So yeah, 10 has factors, but when I look at it as a factor tree, I realize, oh, the factors don't help me reduce this. So this does not reduce. Okay, so I'm going to just leave it as square root of 10, and then I have to get rid of the 7 from the side with the x, so I subtract it. Now again, when we have, this is all real, none of this is imaginary, but when I have numbers like this, where part of it's a radical, part of it's an integer, I put the integer first, so negative 7 plus or minus the square root of 10. So those are real solutions. You can see it actually crosses the x-axis. Okay, that's just an irrational number. And if you get that and you're like, well, I'm not sure if that's correct, you know what it should be as a decimal, these two numbers. Go ahead and type this in and see what it is as a decimal. Make sure it matches. So we've got negative 7 plus, then your square root of 10, negative 3.8. Let's see if that's one of them. Hey, yeah, that's that one. And then we've got negative 7 minus square root of 10. And hey, yeah, that matches the other root. So we did that correctly. That is the correct exact value for the solutions. All right, now we'll take a look at number 9. Number 9 is set up a little different. It doesn't have the x in parentheses being squared. It's just x squared. So we're going to move the constant over first. So we end up with 8x squared equals negative 56. And then we're going to divide out the 8. So we have x squared equals, and remember, I didn't do this at first for some reason. It doesn't matter if you do it at first or at the end, but we could always check it in the calculator as well. But this comes out to negative 7. And when I go to take the square root, I realize I've got a negative under the square root again. So it's going to be imaginary. So positive or negative, I root 7. I know 7 is prime, so I don't even bother trying the factor tree. There's no factors of 7 besides 7 and 1. Okay, but if I came over here and tried to check that, I get 8x squared plus 56 typed in. I can see it never crosses the x-axis, so that tells me it's imaginary. So that confirms that we should have gotten an imaginary solution. All right, on the next page, we've got some matching here. We want to match the solutions with the roots. Again, I don't know why I just made that full screen because I'm going to use a calculator again. So I'm going to type all of these in. They don't all have to be active at the same time. So I've got x squared plus 5. Got x squared minus 5. X squared plus 25. And x squared minus 25. Now, these don't have to be factored. You can see the graphs. It's kind of, I don't know why it made two of them green. Let's make it a different color, purple. Okay, but you can turn them off and just look at one at a time. Okay, so this first one never crosses the x-axis. So I know it has to be imaginary. So it's got to be the c or the d. Okay, so we'll come back to that one. Let's check x squared minus 5. That one crosses. It crosses at 2.236 and negative 2.236. Now, that's definitely not negative 5 and positive 5, and it's definitely not imaginary. So I don't know what that is as an exact value, but just based on process of elimination, it's not imaginary and it's not 5. It must be the square roots of 5. Okay, and if you wanted to check that, you could type in the square root of 5, and you could see that is the decimal for square root of 5, positive and negative. Okay, so we know that 11 then must be B. Okay, so then let's check C. Doesn't ever cross. Okay, let's check D. D has real solutions at negative 5 and 5. Okay, or excuse me, that's not, I think I said D, number 13, the fourth equation. Okay, so that is A, and number 11 was B. So we've eliminated those. So now the only ones left are the imaginary, and I know two of these are imaginary. Neither of those ever cross, but I don't know which imaginary is which. So I'm going to come back over here and do some work by hand. You could have done all of these by hand. All of these only have one x term, so all of these can be done with the square root method, which is probably what I would have done. I wouldn't on this one because they're pretty basic. I wouldn't necessarily have gone straight to the calculator, but I know a lot of y'all will, and that's fine. But so for this first one, if it's set equal to 0, and I go to, you're replacing 0 for the y, and then you're subtracting the 5 over. So you end up with negative 5 equals x squared. And then you're ready to take the square root of both sides and not forget your plus or minus. So this is the positive or negative, and then the I will come out because the negative underneath. So it's I root 5. So positive or negative I root 5, that is D. Okay, and then we can confirm that. I know there's only one left, so process of elimination, it must be that C, but we'll just double check it. Okay, if we replace y with 0, and then we move the 25 over, we've got negative 25 equal to x squared, and we take the square root of both sides. 25 is a perfect square, so you get the I because of the negative, and the square root of 25 is 5, so you get 5I, which is C. And you could have done 11 and 13 by hand the same way as well. You just wouldn't have ended up with a negative under your radical, so you would have gotten these values. All right, now this says use your method of choice. So I'm going to always start with graphing and see if it tells me the answer. So x squared plus 6x minus 3. So there are two real solutions. Oh, but they're ugly decimals. I'm not sure what those are. Okay. So going back over here to see how I could solve this by hand. If they're irrational numbers like that, I know factoring's not going to work. So I know square root method won't work because I've got two x terms here. So I'm down to either completing the square or quadratic formula. Since we already practiced quadratic formula up above, I guess I'll practice completing the square method on this one for those who like to use that. So it's in standard form already. There is nothing to factor out, no a value here. So we're going to move our, remember this is, we're replacing y with 0. So I'm going to move my constant to the other side. So I've got 3 equals x squared plus 6x. And now I need to figure out what constant should be added to make this a perfect square trinomial. Remember, what we do to one side, we do to the other. To figure out what goes in that blank, remember it's b divided by 2 squared. So your b value is right here at 6. So 6 divided by 2 is 3. And 3 squared is 9. So 9 goes in those blanks. So then on the left, I just go ahead and simplify that. And then over here, I have this perfect square trinomial is going to change into a binomial squared. And remember, what goes in here with x is half of b. So half of 6 is 3. It keeps the sign, so it's plus 3. Okay, so now I'm ready to take the square root of both sides to solve this. Don't forget your plus or minus. So positive or negative square root of 12. 12 is one I can do a factor tree on. Okay, and there I've got a pair of 2's. So a 2 gets to come out, but the 3 has to stay underneath. I've got positive or negative 2 root 3 equals x plus 3. And I still have to move that 3 over to the other side. This is a radical term. This is not, they do not combine. So this stays as negative 3 plus or minus 2 root 3. So it says blank and blank. You can write them separately. You can write negative 3 plus 2 root 3 and negative 3 minus 2 root 3. Okay, if you struggle on reducing those radicals, like I reduced the root 12, if it's a multiple choice question, it's not that big of a deal. You could check and see your final answer. We ended up with negative 3. Oh, I should not have deleted that because we could have checked it. Hang on, let me put that back in there. X squared plus 6. Okay, so I could plug in what I got, negative 3 plus 2 root 3. Is that one of these decimals? It is. Now, if you didn't reduce it and you left it as negative 3 plus root 12, you'll see that's the same decimal, okay? So if it was multiple choice, if this is what you got and that's not an answer choice, check your answer choices and see which one matches what you got. Or if it's multiple choice, you don't even have to bother. You can just check the answer choices as decimals and see which one matches the graph. That would be even quicker. So you can see if we did negative 3 minus 2 root 3, we get that second decimal there. So we get both of those. And so we know we have them correct. All right, on 15, it says still solve your method of choice. So let's check this one out in the calculator. X squared minus 8x decimals again. All right, so we do have to figure this one out. So since I just did completing the square for 14, I'm going to do quadratic formula for this one. And remember, you don't have to have it memorized, but it does need to be in standard form so we can identify A, B, and C. And we want to make sure that we get the correct sign with each of those. And then it's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I simplify, because the negative is in the formula already, and then b was negative, that's going to come out positive. Okay, and the denominator, that's just a 2. So then I just need to figure out my discriminant. Negative 8 squared is 64, and then 4 times 1 times 1 is just 4. So 64 minus 4 is 60. You can do that in the calculator as well. Okay, so I'm going to come do my factor tree for 60. That could be 6 and 10. Be 5 and 2, 3 and 2. So there's a pair of 2's. So a 2 gets to come out. So root 60 would change to 2 root. Then 3 and 5 don't have partners. They stay inside. And 3 times 5 is 15. So 2 root 15. So 8 plus or minus 2 root 15 over 2. Remember, I showed y'all this little triangle. As long as both of these numbers up here will reduce with this denominator, we can do that reducing. So the 8 over 2 is 4. The 2 over 2 is a 1. You don't have to put a 1. It's understood in front of the radical. So 4 plus root 15 and 4 minus root 15. And we could go back and check and make sure that that's correct in the calculator. So I got 4 plus the square root of 15. Yeah, that matches. I got 4 minus the square root of 15. Yep, that matches as well. So we did that correctly. So then, let's see, what have we got left here? On 16 and 17, same thing. Choose your method. So let's double check in the calculator first, see if it's easy peasy or if we have to do a little bit of work. 2x squared plus 5x minus 7. Hey, that's an integer, 1. Hey, that's a rational number. If you don't know what it is, type it in, click here, and it will tell you what it is as a fraction. So we just got 1 and -7/2. And I didn't have to do any work besides plugging it in the calculator. So I'm just going to put calculator graphing. That's how I solved that. All right, let's see if 17 is as straightforward or not. So that one's 2x squared plus 28x minus 4. Decimal again. Okay, so we are going to have to do some work on this one. I've reviewed the quadratic formula method and the completing the square. Well, I did quadratic formula twice, so I'll do completing the square again. So you have that one twice. So if I'm going to do completing the square, the first thing I want to do, it's set equal to 0. I want to take out a GCF if possible. So here, all of these are divisible by 2. So I'm going to take out that GCF of 2. Divides over to the other side, which will stay 0. So this is what I've got now. And then I move the constant to the other side. So I'm going to move up here. So I've got x squared plus 14x. And I'm going to have my plus blank. And that's equal to 2. And I'll have my plus blank. So I'm going to figure out what goes in that blank by doing b divided by 2 squared. B is 14 now that I took out the GCF. So 14 divided by 2 is 7. Squared is 49. So 49 goes in the blanks. So this perfect square trinomial will become x plus 7 squared. And then 49 plus 2 is 51. So then we're ready to take the square root of both sides. So I end up with x plus 7 equals the positive or negative square root of 51. If you are unsure if the number under the radical has factors for you to try and do a factor tree, let me remind you in Desmos how you can check for factors. So you can add a table, and instead of y1, we're going to put in the number we want to know the factors of divided by x1. And then we're going to start typing in 1, enter, 2, enter, and then it'll start self-populating and you can make a big table. We're looking for integer factors. So 1 and 51, 3 and 17, and all the rest look like decimals, and you can keep going. But 3 and 17 is the only thing I see. 3 would be prime, 17 also prime. Nothing we multiply is going to give us 17. So that doesn't get us anywhere with a factor tree. So that square root of 51 cannot reduce, cannot be simplified. So I will leave it. I just need to add the 7 over to the other side. So this would be written as 7 plus or minus the square root of 51. 7 plus root 51, 7 minus root 51. And we can check that because we have the graph over here. So let's see if those decimals come out to what the graph shows. So 7 plus square root of 51, 7 minus square root of 51. Yes, they do. Those decimals match what we got with those radicals. So we've done that correctly. All right, down to the last two. I've already fixed it on here, but number 19 did have a typo on the printed. It had an X there, so make sure you change that to a W. These variables should be the same. All right, now these are word problems, but it doesn't change how we solve for a quadratic. We just have to interpret it in terms of the scenario. So in 18, it says, for a science project, Joseph launches a model rocket. The function h of x, and they give you the equation, represents the height in feet for the rocket after x seconds. So x is the number of seconds, and what this equals, h of x, is the height of the rocket. It says, how long will it take for the rocket to hit the ground? If your rocket is hitting the ground, you don't even have to visualize this. If I were to draw, I mean, you do have to visualize it. I mean, you don't even have to look at it in the calculator to be able to visualize this. Okay, he launches a rocket. Now, I don't know if it's from the ground or not. So my starting point, my y-intercept may be slightly off, but he launches a rocket. It's going to go up and then it's going to come down and it's going to hit the ground. Right there is where it hits the ground. That is where y is 0. It hits the ground where y is 0. Okay, and it wants to know how many seconds. Okay, seconds is this. So they're looking for that length there. How many seconds? What is the x value when y is 0? That's what the question is asking. So that we're going to do this in the calculator. I'm going to type this equation in. Or x squared plus 3x plus 52. All right. Oh, I wasn't even looking at the equation when I talked about that. Of course, the C there, that's your y-intercept. So he launched it from 52 high already. I don't know if it told us if that's meters or feet or what. It says in feet. So he launched it from 52 feet in the air already. So my graphic is a little off. But so we can see that intercept up there is at 52. Okay, he launches it. It goes up a little bit and then it falls down, falls, all the way to the ground. This is the ground, where y is 0. Yes, the parabola shows it going past. The rocket's not going to go underground. This calculator doesn't know what this equation is representing, what real life scenario, so it's showing the entire parabola with a domain of all real numbers. Okay, but this part to the left of the y-intercept and this part under the x-axis don't exist for this scenario. Okay, so keep that in mind. So let me just redraw that for you. Started at 52, went up, and then fell. Okay, so, and this is what they're looking for. So that point right there, we just established was 4, 0. So it took 4 seconds for it to get to 0 feet in the air. I don't care about this other solution because it's negative and it doesn't exist in the actual real life scenario. All right, let's read this one. So they give us the equation. It says this can be solved to determine W, the width in feet of a rectangular enclosure. Find the width of the enclosure. Okay. All right, so back, where is it here? I'm going to put in this equation. Now I'm going to use X instead of W. That doesn't matter though in terms of Desmos. All right, so here is our graph. Now think about W. W is X. So our X-axis is representing the width. Okay. It says that this equation can be solved to determine W, the width of the rectangular enclosure. Solved. If we are solving the equation, we are looking for the solution, the roots, the zeros, the x-intercepts. So that's all we are looking for on this graph are the x-intercepts. But if we look, we have one negative and one positive. In this scenario, with W representing a width of a rectangle, it does not make sense for it to be negative. You're not going to have a negative width. So you ignore the negative solution. It is only the positive solution. So it is 8. So we solved it and we got -2 and 8. But the fact that that is negative doesn't make sense. So it is only 8. 8 is your answer. And it's in feet. So 8 feet. All right, and that is it. That is the entire review. If you feel like you need more practice, you can go back and watch the video over the FAs. There's a video. Let me pull up Canvas real fast. Here in Canvas on our calendar, you can see we went over FA2 on Wednesday. You could watch that video to hear an explanation of some of those questions again. And today in class, we went over that mixed practice FA, the one that was on paper. You can watch that video for some additional practice or explanations. You can always go back to this the Delta maths that are still open as well. Even if you completed it, it won't stop you from doing extra problems. So you can go back in your Delta maths and do extra problems for practice if you would like to. That is that.